welcome our final panelist, Dr. Bo Zhao. Dr. Bo Zhao is an associate professor in the Department of Geography at the University of Washington. Prior to that position, he was an assistant professor at Oregon State University after completing a postdoc position at the Harvard Kennedy School of Government. Bo's research lies at the intersection of GI science and human geography. He has developed a unique humanistic approach to examining GI science and technologies, especially for the interests of vulnerable populations. He has a very special publication, recent publication titled Deepfake Geography. I'm sure everyone knows that, right? Deepfake Geography, when geospatial data encounter artificial intelligence. It was published in the CAGES journal in 2021, right? About a year ago, a little bit more than a year ago, but it really went viral online and received an L-metric score of 362. I checked this morning, early in the morning. Well, anything beyond the L-metric, anything above 20 is already exceptional to me, my standards. This is huge number, really. So the work urges GI scientists to develop coping strategies to the ambivalent nature of GeoAI in the age of post-truth. Welcome, Bo.
Yeah, thank you. Thank you, Angela, for this wonderful introduction. Thank you, Dr. Meng, and morning, everyone. So what I would like to think with you today is my recent research on deepfake geography, its social implications, and ways to detect them. With this empirical study, I want to further reflect upon the geospatial data integrity issue with a vision towards GIS and the cartography in the so-called post-truth era. So as just Dr. Yao mentioned, this paper got viral and a lot of attention from media outlets, industry, and academia, as illustrated in this slide, that the three major geography associations in the North America have reported this work. As a leading author, I initiated this project to profoundly reflect upon the potential challenges of GeoAI on our society and our everyday life. Deepfake geography, in a narrow sense, describes realistic satellite imagery that has forged by GeoAI in order to illustrate a landscape that doesn't exist in the real world. The satellite imagery, under most circumstances, cannot be distinguished by human eyes. While many GIS practitioners and cartographers have been celebrating the technical merits of GeoAI, deep learning and other type of AI for geographical problem solving, few have publicly recognized or criticizing the potential threats of GeoAI, especially the deepfake geography. As warned by the former Chief Information Officer at the National Geospatial Intelligence Agency, deepfake geography is the newest AI-enabled weapon, using his own word, the deepfaking photos of the Earth. He also pressed the urgency to study deepfake satellite imagery, as he indicated some countries are already doing it right now, using GANs, which is a typical generative AI, to manipulating scenes and pixels to create things for nefarious reasons. So I think it's a time to think about ways to detecting the fake satellite imageries. As a researcher, to better cope with this deepfake geography, we need to first understand what deepfake satellite imagery is generated. And also we need to collect a large collection of deepfake satellite imagery to learn their features in order to helping us to detecting them. So we use the generative AI to synthesize satellite imageries. Considering the time, I probably will skip the slides, but if you want to have interest in this technical process, we can bring it up in the QA session. So here on this slide, the top two shows a real Google Street Map on the left and its correspondent auto image on the right. And then we show two synthetic images on the bottom as you can see clearly that the landscape structure are pretty much the same, but the geographical scenery are changed dramatically. Along this line, we also generated satellite imageries of different platforms of cameras, like Google Earth imagery at different zoom levels, Sentinel-2 and Landsat 8. As you can see, those images are so realistic. Our lab have used 500,000 images to reach a realistic level like this. So that reminds me some of the arguments which Dr. Meng has mentioned, seeing is believing, and which were, when I heard her presentation, I was thinking how we can unlearn this very intuitively conscious, right? Perhaps really difficult. So to detect the deepfake images from the authentic ones, we reviewed the previous papers and proposed a post-vector machine approach to learn 12 salient features of deepfake satellite imageries. The features are from the spatial domain, the color histogram, and frequency domain. The approach reached the F1 score more than 0.95 when taking all 12 features into consideration. Here, the F1 score is a measure of the model performance. It combines the precision and the recall rate in a single metric. The higher the value, the model is more accurate. So previous slides mainly showed our research progress by 2019. Since then, we have initiated a few new directions to cope with the deepfake geography. First, we're thinking about NFT-based satellite imagery licensing system. So NFT, non-fungible token, a newly emerged approach to manage, recognizing, and protect the copyright of digital arts. We cartographers or geoscientists may recognize the authenticity of a satellite imagery using a blockchain non-fungible tokens. Secondly, it is also possible to develop an API to detect authenticity of a satellite imagery, like how Twitter notifies the trustworthiness of a tweet. Another approach to dealing with the spreading of fake satellite imagery is to build a scientist-led public-facing platform that allow people to share their opinions towards the authenticity of satellite imagery. We're thinking of doing this because we believe that rather than immediately telling people what is true or not, it is more important to allow people of different opinions to discuss or offer their own interpretations of the ground truths to debate and to discuss. Moreover, in today's so-called post-truth era, the process of determining truths has been deeply influenced by people's emotion. There is a strong motive from the public to let the scientists to lead the process of determining what is the truth or fake. Because of these two major reasons, we propose this public-facing fact-checking platform. Now, let's go back to the thing of the plenary session, the integrity of geospatial data. My work on deepfake geography is definitely related to this general concern of integrity. But beyond this, I sincerely believe that the geospatial data integrity can be better examined by a rewire of geoscience or cartography, and also by rethinking about the social implications of geospatial data in today's post-truth context. This kind of rewire and rethinking allow me, actually reminds me of an AAG session that I co-organized in 2019. Today, a lot of these research topics are still yet to explore. For example, like rethinking of the ground truth, spatial data quality, uncertainty, and also how we can detect fake locations, proof of locations, and also understanding the spatial dissemination of fake location information, critique of fake location information, like checking, geotag, location-based review, and so on and so forth. Also, case studies of geospatial data falsification is also important. Along this line, I also, with several other, my co-authors, work on a paper named Standing #StandingRock, Invasion Epistemology Shift in Understanding Geospatial Data in the Post-Truth Era is also try to shine new lights on this issue. Okay, that's all I want to think with you into this presentation. To the end of my talk, I want to express my gratitude to my co-authors, Yifan Sun, Chunxue Xu, Shaozeng Zhang, and Mia Bennett, and Peng Bing De. Thank you so much.